So now let's move on to the seventh question. The seventh question is as follows. A concave and a convex mirror both having a radius of curvature of 60 centimeter face each other 100 centimeter apart. Okay, and the object is placed between them. The image after n, where n is less than equal to 3, reflections, the image after n with n reflections, of which the first is at the concave surface, coincides in position with the object. That means after n reflections, the image is exactly at the same location at where the object is. Okay. Now the question is, find possible distances of the object from the concave mirror. Basically, I need to find the position of the object on this place. My question is, there are two mirrors, one is concave, one is convex, both having a radius of curvature of 60. The distance between them is 100 centimeter. Somewhere here the object lies such that after n reflections, the final image coincides in position with the object. So the question is, where is this object kept on this axis? Okay, very simple question, isn't it? So let's see how to find the solution of this question. The question is a very good question indeed, so I hope you will try this question on your own first. So it is given that n is less than equal to 3, the number of reflections. So I have to take 3 cases when n is equal to 1, n is equal to 2 and n is equal to 3. Okay. Okay. So first of all, let's draw the diagram. This is the concave mirror, this is the convex mirror. Let's say the object is kept somewhere here, a distance of assuming x from the concave surface. So first case, n is equal to 1, that means only there is one reflection, there is no reflection on the convex surface. So the final image coincides in position with the object after reflection from the concave surface. When can that happen? That can happen when the object is placed at the center of curvature. Remember, when the object is at center of curvature, the image is also formed at the center of curvature. So that means my u is equal to v should be equal to center of curvature, which is equal to the radius distance, which is equal to how much? 60 centimeter. Okay, so when n is equal to 1, the object should be placed at the center of curvature. Now let's see what happens when n is equal to 2. Now when n is equal to 2, let's say this is my position of the final image, and let's say my intermediate image is formed somewhere here. Okay. Let's assume that this distance is y. So for the concave mirror, let me write the equation. 1 by u plus 1 by v is equal to 1 by f. That means what? 1 by u is positive, x is positive, v, how much it is? 100 plus y. See, v lies in the real space, so it's 100 plus y is equal to 1 by 30. Focal length is also positive. Now, this is my first equation. Now, for the convex mirror, where is the object? The object is here. To move from the object to the mirror, I move in this direction, but the incident ray is in this direction. So, my u is negative. So, 1 by minus y. This is the virtual space, this is the real space. My final image lies in the real space, so it is positive. And what is that? 100 minus x, I guess. Yes, 100 minus x, right? This is equal to 1 by 30. Is it positive or negative? Negative, because the focal length lies in the virtual space. So this is my two equations. These are my two equations. Two equations, two unknowns, x and y. Try solving this. If you solve this, you will get x as 40 centimeter and y as 20 centimeter. You can verify this. If you put x and y here, you will see that these two equations are satisfied. Now, let's move to my third case, when there are three reflections. Okay. So let's remove xy now. Let's start fresh. Okay. When there are three reflections, what happens? This concave mirror will form an image somewhere that will be reflected. Let's say it forms an image here. Okay. Now, let's say this concave mirror forms an image at this position. Okay. Now, if I use principle of reversibility, that means if an object is placed here, then its image will be here, because when an object is placed here, its image is here. So, if I place an object here, then the image will be here, right? But what is happening here? Here, what is happening? This position, because of this convex mirror, will get shifted somewhere where the convex mirror will form an image. Let's say the convex mirror forms an image here. So, this position is getting shifted here. Now, if I use the principle of reversibility, if then an object is placed here, it won't form an image here because of the shift, right? So, what I want to say is that for this mirror to form an image at this position, finally, it should see the object at this position only. Then only it can form an image here, because when an object is here, the image is here. So, it has to see an object here only, so that it forms an image here. That means the effect of the convex mirror should be nullified. When can that happen? When it will happen when the convex mirror forms the image at the same position where the object is. And what are the cases at which the convex mirror forms an image at the same position? There are only two cases: when the object is placed at the pole, or when the object is at the center of curvature. That means if this concave mirror forms the intermediate position at its pole or at its center of curvature, then the convex mirror will again form the image at the pole, if the or at the center of curvature. So the effect of a convex mirror is getting nullified, right? So my first case when that will happen is when the intermediate image is at pole, so that the convex mirror again forms at the pole. Second case, when the intermediate image is at the center of curvature of convex mirror. Okay, now let's solve both the cases. When the intermediate image is at the pole, here that means for the concave mirror, 1 by u plus 1 by v is equal to 1 by f. I know what is v. V is my 100 centimeter and focal length is 30. From this, if you solve u, you will get u as 300 by 7 centimeter. Now in this case, 1 by u plus 1 by v is equal to 1 by f. What is v? V is this whole distance. This is 60. This is 100. So So it's 160. From this, if you solve u, you will get u as 480 by 13 centimeter. Okay, so these are my two answers. Okay, now we'll solve one last question before we proceed to our next part of this big chapter, that is refraction. Now, before I give you the last question, I want to discuss something.